lesson 31B, and we'll begin with the scripture in Psalm 94:19, wonderful, comforting scripture that says, "When the cares of my heart are many, your consolations cheer my soul." Now, we all know that our hearts can be concerned. We can have concerns. We can have concerns about what is happening in our own lives. We can have concerns about others, what's happening in those we love, around the world, disasters, you name it. And these things, even though maybe we live in a intense time right now with COVID, these things are actually perpetual in our lives. Concerns, their intensity ebb and flow, but our lives are full of cares. And so what he says, when the cares, not if, but when the cares of my heart are many, your consolations, your comfort cheers my soul. So God gives us what I would call supernatural or peace and joy in the midst. The scripture says he gives us the peace that passes understanding. It means it would be beyond everything you can imagine that you could have. God's peace steady in your heart, comforting your heart, even in the midst of great trial, personal or general tragedy or being overwhelmed. When our hearts are overwhelmed, he comforts our hearts. He brings in supernatural peace, joy, and steadiness. So remember that. That's a fantastic promise. And so I would encourage you, whatever is troubling your heart today, take it to the Lord, put it in his hands, and ask him to give you his comfort and his sense of peace in the midst of it. God bless you. All right, now we're going to read our answers on 8.30 and 8.31. Go over a few review problems, and then on to several more lessons here. So go ahead and get your homework if you have not already, and your book. You will definitely need your book for looking at illustrations today in our geometric section. All right. Now this first section is about the area of a circle, and the area of the circle, the formula is pi r squared. And again, we talked about how that was derived. If you want to go to page 340, you can see the pictorial view of how that was derived. Now, our answers then, it's simply we're going to use 3.14 for pi, and you're going to square your radius and then multiply it out. And you're certainly free to use a calculator for this. Your answers should be 78.5 square inches. Next, 116.84 square feet. Next, 28.26 square inches. Next, approximately 0.13 when it's rounded square feet. Next, 162.78 square inches, and finally 314 square feet. When we go down to the sharpening skills, I don't think you need me to do any one of those, but let's just go ahead and do number 6 by way of review. It's if the radius is 10 feet. When I square the radius, I'm going to get 10 times 10, or 100, and I multiply that by pi, 3.14, and you're going to get 314 square feet. And that's all that does here. Now, when we go to sharpening skills, we have we skipped over the table, and so we want to do the formulas. Perimeter of a square, P equals 4S. Area of a circle, A equals pi r squared. You should have these so that they're very familiar to you. Area of a parallelogram, A equals base times height, and height always means the vertical height. Next, number 10, perimeter of a rectangle. We could write this a couple of different ways, but they're going to write 2 times the length plus 2 times the width. I could as easily have written it 2 times the length plus the width, because you know when you distribute that, it's the same thing. Next, number 11, circumference of a circle, C equals pi times diameter, or C equals 2 pi r, because 2 times the radius is the same as the diameter. Area of a a triangle is 1/2 base times height. And again, that's vertical height always when we see that H. Trapezoid would be the most complicated formula you have, but it would be the height times B1 plus B2, both bases, the top one and the bottom one. And the whole thing divided by 2. And you can go back and review how that was derived, if that's helpful to you. Area of a square is S squared. S just means the side because it's only one value, right? And then when we go to find these answers on the last 3, we would go ahead and use those formulas. So 15, finding the area of a trapezoid, you calculate it out, it's 77 square feet. 16 is 39.69 square inches, and 17, 1/2 base times height for the triangle, 180 square feet. Now, moving on to the next assignment, we'll give you your answers for 8.31. Number 1, triangle and rectangle. Number 2, 800 square feet. Number 3, 3 gallons. Number 4, 28.26 square yards. Number 5, 78.5 square yards. And when you subtract, you'll get 50.24 square yards. Moving on to the next problem, number 7, 18.84 yards, 31.4 yards. Number 9, 69,875 square feet. Next, 855 square feet. Next, 102 pounds. Next, 153.86 square inches. Next, 196 square inches. Next, 42.14 square inches. When we go to the problem solving, your answers should be number 1, 3,768 feet per 10 minutes, in 10 minutes. Number 2, 785 feet. Number 3, 23 feet. And number 4, 8 feet. The sharpening skills, we'll skip over the table. We have some formulas here, beginning with number 5. A equals 1/2 BH. Number 6, C equals pi D, or C equals 2 pi R. Number 7, P equals 4S. Number 8, A equals H times the quantity B1 plus B2 all over 2. Number 11, we're identifying figures here. Ray, then line, then parallel lines, then perpendicular lines, then octagon, then triangle, then hexagon, then a line segment. Number 9, we're finding the area, or 19, beginning with 19, we're finding area. Your answer should be 64 square feet, 13.72 square yards, 1,661.06 square inches, 20.25 square feet, 46.5 square feet, and finally the trapezoid, 266 square inches. Now, I think because of the way they do those more difficult area problems and they walk you through the logic, I'm not sure that there would be anything there that you would need to have explained. But if you do, text me. That's always the rule, right? Text me at 505-301-1357. Tell me, right, your name, the class you're in, and the problem, the lesson that you're having trouble with, and the problem number. And then I'll make sure that the next time I do a tape, I'll make sure I go over it. So that's always our rule of thumb. Now let me, though, do the problem-solving ones here. Number 1, Ferris wheel that is 40 feet in diameter, goes around 3 times per minute. How many feet would be traveled in 10 minutes? So let's go ahead and write that one out. Okay, so I draw a diagram of the Ferris wheel. It's 40 feet across its diameter. It goes around 3 times in a minute. So I want to know how many feet it travels. So that's what is the circumference, how far around it goes. So the circumference is pi times d. You multiply 3.14 times 40, which is the d. Get your calculator out. Now that is the distance around 1 time. And so then you're going to multiply it by 3 because it goes around 3 times every minute. And that gives you this answer here. And we want to know how far does it go in 10 minutes. So then I will multiply it by 10. And that will be my answer. So again, any others that you have trouble with, please go ahead and ask me. All right? Now, let's go to a new concept. We're going to go to geometric solid shapes 8.32. Okay, now we're moving on to three-dimensional geometric shapes. So when I think of a prism, can you think of a prism that you hold and look at the light with? Well, there are a lot of different kinds of prisms, but let's think about that one to begin with. The front face, and I'm not going to be very good at drawing these perhaps, okay, and the back face are the same shape, the top or the bottom, okay, and then you connect those with straight lines. Okay. And this would be the back one. I probably should go ahead and, it's not very well drawn there, but that's all right. You kind of get the idea. I should really kind of, the more I try to fix it, the worse it gets. Okay, let's try it this way. Okay, we've got the front. This is the front. Okay, and those are the other sides. So the front, the key to a prism is the first face and the back face are parallel to one another, and they're the exact same shape. And then you draw lines to connect them. If I had so that would be a triangular prism. If I had a rectangular prism, I can do it like I normally do it, and that'll be maybe a little bit easier. Okay. There we go. And so this will be the back part. There, something like that. Where the front square, the front face, and the back face are the same, and then you draw rectangular lines. So this is a rectangular prism, and this is a triangular prism. If we had a rectangular prism where the back and the front are both squares, and as well as this length here, so all this length, and this length are all the same, then we call this kind of rectangular prism a cube. Think of a dice that you roll or anything else. You're probably very familiar with that. Now, pyramids. Pyramids come to a point, a three-dimensional shape that comes to a point. Now, it can have any shape as the base. That's a polygon, any polygonal shape. So I'm going to make a kind of like a base like that, but as long as it comes to a point, it's going to be a little hard to see. Okay, that's a pyramid. Okay. I could have had a, let's say a pentagon. Doesn't even have to be regular. And if it came to a point, that's a pyramid. But often what we have, if we have a square base, this would be named a square pyramid, okay, because the shape of the base is a square. And the last three shapes we're going to talk about are related to a circle. If we have a circle on the front and the bottom, and we connect it with straight lines like that, that's called a cylinder. If we have a circle on the bottom and we connect it to a single point, like the idea of a pyramid, but it's a circle base, we call that a cone. And finally, if you have a circle and you connect it with a circle in all these directions here, circle all the way around here, like we think a ball, we call that a sphere. So 3 there with regarding a basic circle shape. And I think you probably know those names, but go ahead and test yourself by going to 8.32. We're not going to assign this as a written assignment, but on page 345, and let's just look at those very quickly. Number 1 is a cone, a cube, a pyramid, a cylinder, a triangular prism, a sphere, and a rectangular prism. So just check yourself and make sure that you know those answers and you can recognize these shapes. Because what we're going to do now is figure out, now we've done the area of two-dimensional figures, so now we're going to learn how to find the volume of three-dimensional figures as well as the surface area of a three-dimensional figure. Now let me go to the next page and show you briefly what is meant by those two terms. Now when we talk about surface area, we mean what is the area of, notice this, this rectangular prism here that I have. I have how many sides in all? I have this front side. Oops, let's not do it that way. Let's try something like this. I have this front side here and the back side, so that would be 2. We have a front and a back. We have a left and a right side. There's my right side, and that would be my left side over here. And finally, I have a bottom and a top. Let's pick another color here. And so this would be my top, and that would be my bottom, right? So when we talk about the surface area, we are talking about the area of all 6 of those rectangles. So I would need 3 numbers here. I would need my length, my width, typically we would measure it this way, the length, the width, and the height. Now, when you're finding the lateral surface area, you want to leave off you want to only find the surface area of the side. So look at my diagram again. I don't want to find the top and the bottom. Well, the top and the bottom was my length times width. So the surface, lateral surface area would only be 2 times the length and height and 2 times the height and width. So it wants to be all of this, but leaving off the top and the bottom. So there's your second formula. Now when we're okay, let me go to the next page here, do an example. Well, we've done an example for that. Let's look at the next idea now. Now we're moving on to 8.34, and we're talking about the surface area of a cube. Well, because each surface, how many surfaces do we have? I didn't draw that for the background here, but how many surfaces do you have in a cube? You have the front and the back, the left and the right, the top and the bottom. So we have 6 surfaces, and they all have the same number of inches per side. That would be my S. So I would just say, what's the area of the first? Just the front? What's the area of this surface? Would be S squared, and I have 6 of them. So the surface area of a cube is simply the surface area of one side and multiplied by 6 because you have 6 sides. All right, so let's see. I think that is pretty straightforward. Lateral surface area of a cube. We want to ignore the top and the bottom. We just want to look at the sides. So how many sides do we want to look at? 4. And that would be that formula. So for your homework now, you're going to be doing 8.33, that would be rectangular prisms, finding the surface area, 1 through 8 all. 8.34, that would be cubes, finding the surface area and the lateral surface area on both of those. We do both surface area and lateral surface area. And the sharpening skills 1 through 6, all. Now we're also going to start you on part of 8.36, which is your review. So that I want you to do 1 through 20 now. We'll come back next lesson and pick up some more of those problems because that's just a review. We'll also send you a quiz. I will send it by email. It will be quiz 23, going over lessons 8.25 through 8.29. You are to mail back your answers by postal service. Okay, mail back the answers. Now, basically, we're kind of in a format where you can mail every 2 weeks rather than every week, just to save you on postage. So that means if this is going out on Wednesday, April 22nd, rather than mailing it back this Friday, because you have other things you need to mail back this Friday, you can wait. You could either enclose it this Friday or you can wait and mail it back next Friday. Okay, or two Fridays even from now, when you get the other quiz next Wednesday. Probably have a test actually at that point. All right, so the point is you don't have to mail back your work every single week. You can save it a little, but when I give you a reminder, as I did last lesson, on what things were absolutely due by a certain date, that's when you need to pay attention to put it in the mail. All right, so have a great day.